Chemical weathering. So this is the weathering that involves a chemical reaction. The reaction is going to happen in the presence of water. There's going to be ions. There's going to be oxygen involved. The reaction is going to create something new. So what are the products of that reaction? The products are going to be things like fragments of primary minerals. So minerals that haven't changed in that whole process, chemical weathering process. Newly formed secondary minerals. We can transform one mineral into another during these chemical reactions. And then another thing that's going to be created is dissolved ions. So once you've weathered that rock, this is oxidation on the surface, that can produce then ions that are going to be washed away downstream. Okay. From that, we're making sediment. We're making the parts that are going to become sediment and soil later, either in the form of those primary minerals that didn't change during the reaction, or the new secondary minerals that are created during the chemical reaction. Okay, so here is what the general equations look like for chemical weathering. You have the primary mineral in a rock in the presence of oxygen in an acidic environment. So there'll be an acidic solution. There's going to be something that happens there, a chemical reaction, and then the result is going to be that sediment, primary and secondary minerals, and then the dissolved ions that are washed downstream. Okay, we have three kinds. And those three kinds are all helped by acids. So acids are going to be, or maybe let's go back. Acids are defined as having a release of hydrogen ions. So if you think about like the term pH, you think of that when you think of acids. pH is like the percent or the per hydrogen, and the um, definition of pH, that number is the negative log of the concentration of hydrogen atoms. So hydrogen plays a big role in what is an acid, and that is what's going to be reacting to create these chemical reactions and chemical weathering. Okay, so hydrogen replaces cations of other elements because an acidic solution is going to have extra hydrogen on surfaces of exposed minerals, and that is chemical weathering. The main acid in these reactions is carbonic acid. Carbonic acid forms naturally in the atmosphere because there's carbon dioxide in the atmosphere, and the rain comes through that atmosphere, picking up the carbon dioxide and taking water plus carbon dioxide and making carbonic acid. So unpolluted rainwater has a pH in here of about 5 or 6. In soil, the pH is a little bit lower, meaning more acidic, down here at 4 even. So we have the natural environment is naturally a little acidic. 7 is the a neutral solution. Okay, here's the first example. This is dissolution. I'm going to turn off my face. Dissolution is a reaction between CaCO3, which is the mineral calcite, and carbonic acid, H2CO3. You can see in that chemical formula where that is carbon dioxide plus H2O water. When calcite is dissolved through dissolution in the presence of carbonic acid, that gives off two different ions, a calcium ion and a bicarbonate ion group. The weathering of limestones and marble. So calcite is the mineral name, limestone and marble, and also somewhat dolostone, are the rock types that are weathered through dissolution. That creates and leaves behind sinkholes, caves. There's a certain name to the look of the topography. It's karst topography. those ions, calcium and bicarbonate, then are going to enter the hydrologic cycle, right? They're washed downstream, eventually into our ocean basins, and that is a big recycler of carbon and calcium, and then once they're in the ocean basins, they'll be taken up by organisms, and the organisms make their hard parts from them. On the left here is karst topography. You can see that just over the border in Tennessee. And on the right here is a sinkhole. Okay, the next kind of chemical weathering is one called hydrolysis. And this is going to also happen in the presence of carbonic acid. We're going to start with a mineral called feldspar. Feldspar is the mineral that makes up most of the Earth's crust. So it's a really prominent mineral in rocks. So feldspar is an aluminosilicate. We can see aluminum in here, and Si is the Si and the O are the silicate parts. We call it an aluminosilicate. In the presence of carbonic acid, and it needs to get wet with water, what's going to happen is the sodium is going to be bopped out of this formula and water is added in. So over here now, this Al2Si2O5OH4, that is clay. So the Na leaves, we're left with some, Na is sodium, we're left with the bicarbonate ion, we're left with some silicic acid, and over here the new mineral, so this is our secondary mineral, which is kaolinite, which is a kind of clay. This is the most common form of chemical weathering because I mentioned before that feldspar makes up most of the Earth's crust, so very prominent way for rocks to weather. The image here on the left is a look at the surface of the rocks at a popular hiking spot along the parkway near here called Beacon Heights. And on this surface, feldspars have weathered away, and what's left behind are these really jagged pieces of quartz. So if you ever go to Beacon Heights and you see the jagged pieces of quartz, it's because that surface, the feldspars, have turned into clay and washed down to Greensboro or Hickory, wherever, High Point, off the mountain. On the right here is a look at clay. So clay can suck in water, and when it dries out, the water is released, so it expands and contracts and gives us that sedimentary structure called mud cracks. The last kind of chemical weathering is oxidation. And oxidation is something that occurs. I was holding up this rock earlier, that rusty surface, that's oxidation. Oxidation is like rust. So for oxidation, we have a mineral like pyrite, FeS2. It's an iron sulfide. And the iron is combines with oxygen in the presence of water, and we get rust, hematite. So that surface there, that is hematite caked on that surface. And then there's a release of sulfuric acid. This is a very common reaction that happens in old mines. So I have highlighted here the term acid mine drainage. And an image here of an old mine. What happens is in these old mines, the excavation and the stirring up of those rocks and the big tailings piles, those get rained on and they are exposed, and the exposure of all that pyrite creates an acidic environment, and sulfuric acid then comes out of the mine. That's acid mine drainage. It's usually because of these sulfide minerals. All right, one neat thing to look at here, I'll turn my face off again. Here is a cube. It's 2 feet on each side. Yep, 2 by 2. So this area of that side of the cube is 4 feet squared. A cube has 6 sides, so now the area of this cube is 24 feet squared. I've added 4 plus 4 plus 4 plus 4 plus 4 plus 4. So those are a 6-sided cube has 24 feet squared. If we take that same cube over here the image on the right, and we busted up either by frost wedging or root activity or spalling or exfoliation jointing, whatever the process is, breaks that rock up over this plane, and this plane. Now we have a bunch of cubes. They are 1 foot on each side, and they have 6 sides, so each cube has 6 square feet of area exposed. And there are 1, 2, 3, 4, 5, 6, 7, 8 cubes. So now we have 48 square feet of exposed cube, and now let's say rock. So that's how all of these different weathering processes kind of feed on each other, that we started out with a solid rock, busted it up, and now we have more exposed area, more places for those acids to eat away at the rock.